Hello guys, I'm continuing on my tutorials, my recursion tutorials, and today we'll be talking about number conversion. We'll convert the Denary number to a binary number, okay? And of course the conversion will involve recursion. So actually I declared two lists over here, and I declared a integer n variable, which is an integer variable, which asks for a console read line, so the user will have to input a number and it will be a Denary number, so for example 15, 25, 115, 200, etc. And then I have a reverse list method over here. Just a second. Reverse list, yes, and we're actually calling from the library a built-in method which will reverse our numbers. And then for each display those numbers. Okay, but let's go to the recursion. So we have a list method. So this method returns a list, and we have two parameters: integer input decimal, and another parameter is also a list, which we'll use to store bits, to store actually binary numbers. Okay, so now we declared a inside the method we declared an integer remainder, and this remainder over here will actually get the remainder of the division of the input decimal. Okay, so for example, if you have number 5 modulo, this sign is actually called modulo, 5 modulo 2 will be 1, because 2 can go 2 times into 5, and the remainder will be 1. Okay, now let's say we have number 11. 11 in binary is 1011. Okay, so if we look at this remainder is equal to input decimal modulo 2. So 11 modulo 2 is 1, because 2 can go into 11 10 times, and the remainder is 1. Okay, so we have a 1 over here. So this is the base case, and what the base case actually tells us is that if the input decimal, if the decimal number, which is over here, which we put 11 inside, if it's less or equal to 0, then return the list. So actually it means that the list will be populated. So it will be populated with bits. So the list will contain these 4 numbers. So once it reaches 0, it should already contain these 4 numbers, okay? So this is our base case, this is the place where our method will stop, okay? But if input decimal is lesser or equal to 0, then return the list. Since our input decimal is 11, we didn't change the value of it, it won't go to this if statement, it will go to the else statement. And what it will do, it will add the remainder. And where our list will be populated by this one, by this integer over here, okay, since remainder is an integer. So in our list we have 1 bit which is stored, okay. After that, after the storage, we are going to return the method, okay. So we have actually the recursion over here. And not only will we return our method, but we will decrease the argument. As I told you in my previous tutorials, our goal is to reach the base case. Our goal is to decrease the input decimal, and we are decreasing actually by dividing by 2, because this is actually the way to get to our binary numbers. So input decimal divided by 2 is what? It's 5. It's 5, it's not 5 point something, because it's a input decimal is an integer variable, okay? So now we go up, okay? So we invoke the recursion and we are going up. Again, remainder is now input decimal modulo 2. The remainder will not be 1 now. Well, it will actually, but we'll erase this previous value, and 5 modulo 2 is again 1. Why? Because 2 can go 2 times into 5, and the rest is 1. The remainder actually. Again, we check the if statement. Is input decimal less or equal to 0? No, it's not. Then we proceed to the else statement. list.add remainder. Again, we now have two values in our list. First value was 1, and now again 1. Okay, so we get two values. Okay, our list is populating. Again, we are invoking the recursion, so we have two recursive calls now. Okay, input decimal divided by 2 is, what's 5 divided by 2? It's 2. Okay, because 2 can go into 5 two times. Okay, and this 2, now since the recursion happened over here, it will go up again. Okay, so our method will continue from here. So the remainder will be now what? 2 modulo 2 is actually 0, because 2 can go into 2 once and there is no remainder. Okay, yeah, that's 1. Remainder is 0. Okay, input decimal, is it less or equal to 0? No, it's not. Then okay, again go to the else statement and add the remainder. Now we'll have 3 values in our list. You see 1, again 1, and 0. Okay, so 3 values. Again, we are returning, we are invoking the recursion again, so 3 calls now in the recursion. And we are dividing, we are again decreasing the argument, and we are heading towards the base case. That's our goal. 2 divided by 2 is what? It's 1, actually. Okay, again our method goes up, and just I didn't mention this list. We have to provide this parameter over here. Why? Because the method is asking this. Okay, so if we've put something like an integer over here, we will get an error because the method wants a list. So we're not changing the list, we're just providing it. This is actually what's important. Okay, we are just copying this every time so that our method won't get an error. Okay, so actually we stop here. 2 divided by 2 is 1, and again we go up, and the remainder is now what? It's 1 modulo 2. What's 1 modulo 2? Well, actually the remainder will be 1, because you cannot divide 1 with 2. Okay, is input decimal less or equal 0? It's not, but it will be afterwards. Second call. Then what do? List.add remainder. We are now storing the last bit of our binary number. Okay, and it's 1. You see, now we've got 4 values, and you see that we are done. We store this number, and we are evoking the recursion once again. So 1 divided by 2 is what? It's 0. Finally, we proceed up, we go up, and the remainder is what now? It's not important, but the remainder is 0 divided by 2 is what? It's 0. Okay. And now, is input decimal less or equal to 0? Yes, it is. Then what do? You return the list, and the list is populated. We have our binary numbers, and that's it practically. We return the list after the return statement. We go now to our static void main, and we can see over here that we want to reverse this list. Why? Because our number is actually over here. Our number looks like this: 1101. Okay, it's reversed. Okay, so it's it has an the numbers. We have to reverse the numbers actually. Okay, so to get to 11. So we are reversing the numbers over here, and we are just displaying it. Of course, don't forget this recursion method after the recursive calls. So we have to delete those recursive calls, and they will just go away. So, but I'll talk about this more on my not next tutorial, but the following tutorials. Okay. So I think, guys, that you understand a little bit more about recursion, and that you are getting the concepts, you are grasping the concept, you are getting the idea of the recursion, and that's it for today. Thank you for watching.